Good morning, everybody. Quick announcement before we begin. I normally have office hours this afternoon, but I do not today because I have a PhD defense that I have to go to. So regular office hours will continue tomorrow. So we're in the expansions notebook. So when you type something into your bash shell, the individual words that are separated by spaces are called tokens. And so the shell can replace a token with what's called an expansion. So there's 7 kinds of expansions. I mean, they're listed here, but let's just jump straight into them and see what they do. Right? They're shown in the order in which they have precedence. So the highest precedence is brace expansion. The lowest precedence is file name expansion. We've seen file name expansion already. So whenever you use a wildcard, that's what file name expansion is what's happening. So if you do ls star, the star expands to all of the file names that are in that that are in the current directory. Right? So that's an example of a file name expansion. The star gets replaced with the names of all the files. And so the other expansions work in a similar way. The expansion gets replaced with whatever the expansion is equal to. So we want to be in that directory. Sorry. All right, first expansion is brace expansion. We don't use this very much in this course, but it's useful to know that it exists. So a brace expansion lets you generate strings based on a relatively simple pattern. There are more complicated patterns that you can use, but they're not brace expansions. So a brace expansion has the form, there's some string, so pre is just a string. Then there's an opening brace and a closing brace. Inside the braces, there's some sort of expression. And after the brace, there is an optional string called post. Right? So pre and post are both optional. So pre is called the preamble, post is called the postscript, and the expression is some sort of, it's either a list of comma-separated strings, or it's what's called a sequence expression. It's easier to see an example of this to understand exactly what's going on. Okay, so here's a brace expansion. There's no preamble or postscript. And so this thing generates the string A, then B, and then C, with a space in between. Right? So you have a comma-separated list of strings. Right? Each string becomes part of one. Each string generates its own expansion, like that. So there's an A, then there's a space, then there's a B, then there's a space, and then there's a C. If you have a prefix in front of, oh wait, let's go back here. If you have just one string, like that, then obviously you just get, it has to be a comma-separated list. Oh, so that's interesting. So if you just have that, you don't get a brace expansion. You get the brace A closing brace. This is one of the confusing things about the expansions in bash. If you have an expansion, so for example, if you do a file name expansion, and use a wildcard. So suppose you do something like A star. If there are no files that start with an A in your directory, the expansion doesn't happen, and instead you end up with A star, which is probably not what you wanted. So here, I have what looks like a brace expansion, but you don't get the actual expansion, right? You don't get the string A. Instead, you get the string brace A brace. So that's an unsuccessful expansion. This should lead to a successful expansion, right? So here you get the strings A and B. If you have a prefix and or a postscript, then the prefix and postscript get appended to the front and end of each string of the expansion. Right? So here we're going to get before underscore at the front of every string, and we're going to get after underscore after at the end of every string. What are the strings? Well, the strings in the middle are going to be made up of and then the ampersand, and also. Notice the use of the / here to escape the special meaning of the ampersand. Right? So the ampersand has special meaning to your shell. If you want to use it as a string, you need to escape it or quote it. Right? So you can also quote that there if you like. So if you run that, you get 3 strings, before and after. Right? The second string is before ampersand after. The third string is before and then also after. So instead of a comma-separated list, you're allowed to use what's called a what's it called? Sequence expression. So this generates normally arithmetic sequence of some kind. So your sequence expression looks something like that. So x dot dot y dot dot increment. Right? X is normally an integer. Y is normally an integer. Increment is normally an integer. You are allowed to use characters, but that's because just like in Java, characters are considered to be integers. So 0 dot dot 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Like that. So if you wanted to write a loop over a range, this is one way to do it. Right? So you can generate the range using a brace expansion, and then you can write a for loop using the elements of the brace expansion. So I'll show you how to do that when we talk about loops. You can go backwards, and the expansion is smart enough to know you want to count down. Right? So 9 dot dot 0, you don't need the increment of -1 here. Right? It knows to count from 9 down to 0. Right? And of course, if you specify a step size, it'll take that step size when it generates the sequence. So this will give you 10, 12, 14, and so on, up to 20. Right? The last element of the expansion doesn't have to be there. Right? So if you do 10, 21, 2, the 21 won't show up. Right? You are allowed to use single characters as well, but only single characters. So you can't use strings here in a sequence expression. So here, a dot dot g means a, b, c, up to g. And of course, you can skip characters as well. So a, c, e, and so on. Like that. All right, so why would you want to use a brace expansion? So one use of it is to create a range for a loop. Another example is if you wanted to make a bunch of names that follow some sort of relatively simple pattern. So dates are an example of this. Right? And so here, I want to generate the years 2019 through 2022. Right? And I want to generate the months 0, 1 through 12. So notice again that it's also smart enough to know if you stick a 0 in front of a number in a sequence expression, it will put the 0 in front of all of them if it needs to. Right? So this will give you 0, 1, 0, 2 up to 0, 9, and then 10, 11, 12. And so if you run that, so that just makes a bunch of directories, right? From 2019-01 up to 2022-12. Right? Now remember what's going on here. Right? These are all expansions. So all of that that's highlighted gets replaced with all of these directory names. Right? And so make dir is making each one of these directory names. Right? The expansion gets replaced with the string that it produces, or strings that it produces, and then the command operates on those strings. Right? So expansions first, and then the command operates on the expansions, on the result of the expansion. Similarly here, if you wanted to make a bunch of files numbered 00 through 30, you can do that with a brace expansion. Right? So this one uses touch to make a bunch of empty files called file00.txt up to file30.txt, like that. Right? And so there they all are. And of course, now I've got a bunch of empty directories and empty files sitting in my directory. You can nest these things as well. Right? So here we have a nested brace expansion. So we've got the outer expansion there. Right? And inside the outer expansion, you've got a couple of inner expansions here. Right? It is easier just to run to see how it actually works. Right? So here we have a prefix USR. So that shows up in front of every string. Right? We have no PostScript. Right? Inside the expansion, you've got UCB followed by EX. Right? So there's UCB followed by EX. You have UCB followed by edit. So there's UCB followed by edit. And then you have lib followed by A. So there's user lib A. And then you have lib followed by how X. And so there's your user lib how X. Right? So you can nest these up. I don't know if there's any built-in limit. But you can nest the expansions if you need to. Okay, so brace expansions a little bit uncommon. The other expansions are probably more common. They're certainly more common in this course anyway. Tilde expansion. So we've seen this before. So you know that so previously I told you that if you just write the tilde, that expands to the name of your home directory. right? So it expands to the absolute path of the user's home directory. So if I do echo tilde on my computer, I should get something like user home Burton. Right. Now, if there's multiple users on your system, there probably isn't on your computers, right? But if you are running an actual Unix or Linux system that was meant for multiple users, tilde followed by the name of the user will give you the absolute path of that user's home directory. I don't know if this works on my computer. I don't think it will. Yeah, it doesn't work. So if there was a user named sys220 on my computer, then this would print out something like root home/sys220. I don't have a user called sys220 on this computer, so instead the expansion fails, and you get just the string tilde sys220. Right? So again, there's an example of a failed expansion. Right? If an expansion fails to happen, you just get the literal string. Again, this could cause a problem. Right? So if you were expecting this to actually result in a in a directory path, in an absolute path, and you did something with this, right? So for example, suppose you tried to change this directory. So let's do this. Whoa, sorry, what did I just do? cd tilde sys220, like that, right? I'm expecting sys220 to exist, and I'd like to go into their home directory. This is going to fail. So you have to be a little bit careful about these. You have to be aware that expansions can fail. All right, parameter expansion is sufficiently complicated that we need an entire notebook and probably 1.5 lectures to cover. So we'll come back to parameter expansion later. Parameter expansion is literally getting the value of a variable. Command substitution is an interesting one. So command substitution lets you run a command and grab the output that it generates, and the expansion results in the output that was generated by the command. Right? So it looks like $1 round bracket, followed by the closing round bracket, and then some command inside the round bracket. Right? The command can be arbitrarily complicated. Right? And so the way this works is that command, so your shell launches what's called a subshell, so it starts a new shell. Runs the command in the new shell. If the command generates some output, all of that gets replaced with the output of the command, right? And then the subshell stops. And so you can use this there's many reasons you might want to use this, but one of the things you can use this for is to store the result of a command in a variable, right? And so all commands, not all commands, a command can generate output, right, which is just a string. You can store that string in a variable for later processing. Here's an example where I'm not storing the string. Instead, I'm just using the command substitution. If you're on a Mac, this won't work the way it's intended, I don't think, because the Mac date command is different than the GNU date command. If you use gdate, I think on a Mac, it should work, I think. Not 100% sure if that's true. I don't know if there is a gdate, if there's a GNU version of date when you install core utils. Okay, so what's going on here is that there's a command. So there's the date command. So date plus %a. So let's run that on its own inside of a terminal somewhere. So date, sorry, what was it again? Date plus %a. Okay, so if you just run that, you get Monday. And if you run date on its own, of course, you get the output that looks like this. Right? Well, so it looks like date plus %a gives you the day of the date the full name of the day of the date. Right? And also here we have, I'm just going to copy this because I'm not going to remember it. Oh, sorry, that didn't work. Okay, so it's date plus %h colon %m. So that's going to give you the time with the hour, followed by a colon, followed by the minute. And I don't know if that's on a 12 or 24-hour clock. If you do the man date, it'll probably tell you. All right, so if you wanted to print out today is Monday, it's blah, right? Then one way you can do that is with a command substitution. Right? So here the date command will run, with the +%a option. Right? Whatever output it generates will replace everything that's highlighted. Right? The second instance of the date command will run here with the +%h :m option. Whatever output it generates replaces everything that's highlighted there. That all produces one big string. That all produces one big string, which is then passed to echo as the input argument for echo. So that produces, today is Monday, it's 10:46. It's actually 11:46, but that's fine. Here's an example using cowsay. So we're going to use cowsay to say the string moo, right? But we're going to use a command substitution. So whatever output cowsay generates will replace everything that's highlighted, right? That's just a big string. And so here we're going to store the string in a variable called moo. Right? And so this is a variable assignment right there. Right? There cannot be a space before or after the equal sign in bash. Right? So this makes a variable called moo, assigns it the result of whatever cowsay produced. So if you run this, the output of cowsay does not go to the terminal. Right? Instead, it gets stored in the variable moo. And hopefully so we can echo, now you can echo the result of the variable. Right? Or sorry, you can echo the value of the variable, like there. Notice the $ in front of the moo. So this is an example of parameter substitution, right? Which is one of the substitutions, one of the expansions that I just skipped over. And so to access the value of a variable in bash, you need to write the $ in front of the variable. Right? You might wonder, why do I need to write the $ in front of the variable? Right? So suppose you didn't write the $ in front of the variable. You would do something like echo moo. Well, moo is just a string, so it's just going to print moo. Right? And so if you need a variable, if you want the value of the variable, you need the $ in front of it to tell the shell that you're accessing a variable. You're not just using a plain old string. Right? Like that. So we'll talk more about that when we talk about parameter substitution. All right, arithmetic expansion, not so useful when you're working on the command line, right? So if you're just typing stuff into your shell directly, you're probably not doing a whole lot of math. You might do some, but you're probably not doing a lot. So it's a little bit more useful when you start to write a bash program. Oh, that's wrong. There's a typo here. Double round bracket at the end. Okay, arithmetic expansions. So they look a lot like a command expansion. In fact, they almost look exactly the same. The only difference is it's double round bracket at the front and end. Right? So $, parentheses, parentheses, some arithmetic expression, results, all of that gets replaced with the result of the arithmetic expression. Bash is only capable of integer arithmetic. So there's no real number arithmetic in bash, right? So no floating point. If you want to do floating point stuff in your shell, you probably shouldn't be using the shell. But there are programs that will let you do floating point arithmetic if you need it. Okay, so evaluate the expression as an arithmetic expression, and then replace the entire expansion with the result. The result isn't a number, right? So everything in bash is just a string. So this looks like the integer 1 plus 1, right? Bash just interprets the 1. As far as bash is concerned, it's the string 1 plus 1, right? When you use an arithmetic expression, it interprets the 1 plus 1 as the arithmetic expression 1 plus 1, right? And replaces it with the string, and this gets all replaced with the string 2, right? Not the integer 2, right? So when you run that, you get a 2. Not so surprising, right? So remember how this works, right? The shell replaces the expansion with the result of the expansion, right? So that's going to get replaced with 10, everything that's highlighted, right? String concatenation in bash, there is no special operator. You just stick the two strings side by side, and bash concatenates the results, right? So this results in make dir 10, right? And you end up with the directory dir 10, right? So all of that gets replaced with the result, the string 10, which gets concatenated onto the end of dir, and you end up with make dir 10, which is right there. Right? That's really weird if you're coming from a language like Python or Java, right, where you have to use an explicit operator. to do the concatenation. So again, these kinds of expansions are a little bit uncommon when you're just typing away on your command line, but they are commonly used in scripts. And so we'll talk about that when we talk about writing a bash program. Okay, any questions so far? All right, word splitting. All right, so after all of the previous expansions have occurred, right, so you do your brace expansion, you do tilde expansion, parameter expansion, arithmetic expansions, and command substitutions. So all of that happens, and then anything that's not inside double quotes undergoes what's called word splitting. Right? So word splitting splits a string into separate parts or fields, where each field is delimited by one or more what are called field separator characters. Right? So your field separator characters are normally white space. Right? So space, tab, and new line. And so word splitting results in what Bash calls a list of one or more fields. Right? It's just a list of one or more strings. Right? Okay. So because that Bash does this word splitting, this is why spaces in file names are discouraged. Right? So, whoops. In the notebook, in the notebook directory, what's going on here? Oh, hang on, something funny's happening. Oh, we're back. Okay, there we go. So in the notebook directory, there is a file that looks like that. Right? So sys220 space assignment space solutions.zip. Right? We've already seen an example of running this sort of command before. So the entire file name is everything that's highlighted, but because there's spaces there, right, when Bash looks at this command that you've typed in, right, it splits all of this wherever there's a space. Right? So it uses the current field separator to split whatever is here. Right? So it sees a space here, it sees a space here, it sees a space here, and it sees so it sees a bunch of spaces. And so you have the command unzip, followed by a list of strings, right, or a sequence of strings. And so Bash is going to pass each string to unzip. Right? It doesn't pass the entire thing that's highlighted to unzip. So if you run this, obviously it barfs. Right? It says I can't find sys220, sys220.zip, or sys220.allzip. Right? It's because you're passing, as far as Bash is concerned, you're passing 3 arguments to the unzip command. Whereas you really just wanted to pass in the one file. Right? And so that's why you need quoting. Right? So the way to get around this, of course, is to quote all of this. I don't know if this actually works. I don't know if this is a real zip file in the directory. It's not. So it's just a made-up file. So that's the way you would have to pass in the. That's one way that you could pass in the file name if it was an actual zip file. Right? You could also escape the spaces. Right? So // in front of each space. Okay. So what does Bash use to split a string? So it uses this variable called big IFS, and so that's short for internal field separator. So IFS is just a string. Each character of the string represents a character that Bash will use to perform word separation, word splitting. So on its own, by default, IFS stores the characters space, tab, and new line. Right? If you print it, you just get a new line. Right? You get a space, then a tab, then a new line. But on your terminal, it just looks like a blank line. Right? So every character that's currently stored in IFS is considered a valid field separator. If 2 or more field separators occur side by side, then the shell treats it like one single field separator, which is important. So if you have a string that's got a bunch of spaces in it and you'd like to preserve the spaces, if you allowed word splitting to happen, all of the sequential spaces get replaced with a single space. Right? So you have to be a little bit careful about that too. So here's an example. Right? So here's a string, right? It's double quoted, so that's good. Right? It's double quoted because I've got a whole whack of spaces here, I got a whack of spaces here, I've got a new line character there, and there, and one more. No, that's right, there, right? And so if you write this, everything's fine, right? So the string str is the string field 1, space, 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 field 2, space, 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 right? And so on and so on and so forth, right? Now, what happens if you actually try to print this thing out? So if I print out, so the $sign in front of string, remember, that is parameter expansion, right? So that's going to look at the value of string and replace everything that's highlighted with the value of str, right? So you would like it to print out that, but it doesn't, right? It prints out that. Why does it print out that? So this gets replaced with all of this, right? And now word splitting happens, right? So everywhere there's a space or sequence of spaces, right? Bash replaces that with a single space. So it replaces all of that with one space. It replaces all of that with one space, right? New lines are part of IFS. So IFS includes the new line character. So these new line characters here, they all get replaced with a single space. And now you end up with a string field 1 space, field 2 space, field 3 space, field 4 space, right? Which is probably not what you, well, it may not be what you wanted in this case, right? If you wanted the actual string that you wrote up here, right, you have to prevent word splitting from happening. How do you prevent word splitting from happening? You have to double quote it. Do I do it somewhere? Oh, I didn't do it. That was silly. You double quote it, right? So an expansion inside, well, sorry, a parameter expansion inside double quotes does not undergo word splitting. Right? So now you get the actual string. Right? All right, so again, if you look online for any sort of bash advice, almost certainly you're going to encounter something like, you didn't double quote something, right? This is why, right? It's because this word splitting is happening, right? And it's changing the string that you wanted into something else. If you want to, you can replace the contents of IFS, right? Be careful if you do this though in your shell. So if you're doing this directly in your shell and you replace IFS, any subsequent word splitting is going to use your new IFS to do word splitting, right? Most scripts are written assuming IFS is the space, tab, and new line. So if you change it, make sure to change it back. So here's a string. It looks like student number, last name, first name. Right? So if I wanted to split this on the commas, I can. Right? I just change IFS. So I'm going to remember what IFS is currently set at. So I'm going to use old IFS. Right? $IFS, remember that's the actual value of the string IFS. Now I'm going to replace IFS with just the comma, right? And now if I print out str, did I store str? I have to run this, whoop, right? So now if I print str, it's going to replace all of the commas with spaces. Right? Whoop. And so now I get, oh, where'd it go? Here, there we go, right? And so now I've got my three fields. Right, I've got my student number, I've got my last name, and I've got my first name, all as separate strings. Right? And now you might want to do something to process each one of those individual fields. Notice that the last thing you do is you reset IFS back to its original value, so that all subsequent word splittings happen the way they normally would. Oh, here's an example of processing each field. So there's a little for loop, which we'll talk about in greater detail later on. So that's Bash's version of a for each loop. Right? So a bash for each loop processes a list of strings, right? So a space-separated list of strings. Right? That expansion there results in that string there. Right? So that, as far as Bash is concerned, that's just 3 separate strings. Right? So you can process each field in the string in the list of strings like that. Right? And so this just, that will print out the student number, last name, first name on separate lines. Right? Alternatively, you could do something else to process the individual fields if you needed to. So it turns out there's a bunch of rules. If you really want to know the nitty-gritty details of exactly how word splitting works, click on that link, and it will explain to you all of the gory details of what exactly happens when you do word splitting. What I've explained to you is sufficient for our purposes. Okay, file name expansion we've already seen, right? If you use star or tilde or square brackets as part of a file name, the shell expands the wildcards to match whatever file names match that pattern, right? And then you get that sequence of file names, which then can then be processed by another command. All right, so that's an introduction to the expansions that Bash has. Are there any questions at this point in time before we move on? All right. So next notebook, I think, is Introduction to Scripting. This one. So a Bash program is just what's called a shell script, right? And a shell script is nothing more than a text file that contains a bunch of Bash commands, and that's all it is. Right? So plain text. So you just fire up your favorite text editor, start typing in Bash commands into your editor, right? New lines to separate the commands, and then you can run that thing as though it were a Bash program, right? It runs from top to bottom. So when the script is run, the shell reads the contents of the file, interprets the commands contained in the script, and runs the commands in the order that they appear. So to run a Bash program, you need the script file, right? You need to have permission. You need to have read permission on the script file, and you must have execute permission on the script file, right? So if you try to run a script and it doesn't work, so you might get some sort of, well, let's try to run one. So is there something here? Okay, so there's a hello.sh. So I'm going to, okay. So there's hello.sh. I have execute permission on this file, so I can run it like it was a regular command. Now, if you just type in hello.sh, it's going to complain. Your shell will complain, right? It says command not found. So the reason it complains is because your shell, when you type in a command, the shell looks in certain directories for the command, right? So it looks for a file corresponding to the command. And there's a standard set of places that it looks, right? The standard set of places is stored in a variable called your path. All caps path, right? The colon separates the, so these are just a list of absolute path names corresponding to the directories that Bash will look in for a command. Right, so it'll look in user local sbin. I don't remember what order it goes in. If it goes in the order that it's listed, or if it goes in reverse order. I think it goes in the order that it's listed in. So it looks here first, then it looks here next, and then it looks here next. Right, as soon as it finds the file corresponding to the command that you typed in, it'll now run that command. What's not part of your path is your current directory, right? So the current directory is all of this, right? That's not part of your path. And so what does that mean? It means when you try to run your command, you get this thing here, right? Command not found. Right? So how do you fix this? So you have to tell Bash where is the command, right? Well, the command is in the current directory. What is the name of the current directory? It's dot, right? So ./hello.sh, now that works, right? So now you get hello world, right? So when you run your scripts, right, you're probably, for your assignments, you're probably going to put them in some directory somewhere. That directory is not going to be on your path unless you add it yourself, right? So to run your script, you're going to write ./ and then the name of the script. You also need read and execute permission on the script. Right? So I think we already saw this, right? So I have execute permission on hello.sh. If I take it away, so u minus x, right? So change mod, so that changes the permissions, right? I want to change the permission for the user. Minus means remove, so I'm going to remove execute permission on the script, right? And now if I try to run hello.sh, oh, sorry, hello.sh, right? Permission denied. Similarly, if you take away read permission, you also get permission denied. So you need both read and execute permission on your scripts. u plus x. Right, and now everything. Now everything's fine. Okay, so the problem, of course, is that when you make a script, so touch my script. So normally when you make a file, when you create a file in your directory, either using touch or your file editor, right, the default permission is probably does not set the execute permission for the file, right? So when you're doing your assignments, assignments 2 and 3, right, you have to remember to go in and change permissions on the file, right? So change mod u plus x my script, right? And now you can try to run it as though it were a command, right? So when you're making your files, make sure you have read and execute permission on your files. So you can name your file whatever you want. Bash doesn't care, right? In this course, I'm always going to name the shell scripts with the extension .sh, right? So hello.sh, assignment1.sh, something like that, right? The assignments will ask you to submit files with a specific name. So it'll always ask you to submit a file with that extension. Again, there's no naming convention in Bash. So you can name things whatever you want. I'm always going to name the script starting with a lowercase letter. I'm only going to use letters, numbers, and the underscore in the names. And if it's a multi-word name, I might use an underscore between the words. I might not. I'm not always consistent. Right. All right. There's hello world. There's the hello world script. Right. So inside the script, we use the echo command to print a string. Right. There's the string that I want to print. Right. So hello, comma, space, world, exclamation mark. Right. It's inside single quotes because there's a space and an exclamation mark inside of the as part of the string. Right. And I don't want those to have I don't want those to take on their special meaning to the shell. There's also this line here. Right. So the first line, it turns out, is important. If you're on a Mac, this is the wrong first line. So if you're on a Mac, even if you're in Linux, you can use the following first line: user bin env bash. Right. So the first line of your script should always be that. If you're on a Mac, right? If you're on Unix, root bin bash is fine. Right. So either that on a Mac or bash in Linux/Unix. Right. Oh, sorry, there's a hash bit. Right there. Okay. So what the heck is that first line? So the first line of that file is the hashtag or the sharp sign or the pound sign, depending on how old you are, right? So hashtag exclamation mark is called the shebang. It even has a Wikipedia page, right? So it turns out it's important. So this is a Unix thing. And so if a file starts, if the first two characters of a file start with the hashtag followed by the exclamation mark, and you ask a Unix-like operating system to process this file, that first line, the rest of that line defines what command will interpret the rest of the file. Oops, sorry, back here. Okay, so the rest of this line determines which interpreter is going to run this file. This one's a little bit easier. So this says interpret the rest of the command. Interpret the rest of this file using the command bash, right? So root bin bash. So using the bash shell to interpret the rest of this, to interpret the rest of the file, right? This means the same thing. It's just a bit of a more complicated way, right? So env runs a command in what's called a modified environment. Right? The environment is basically the set of environment variables that are set. So here, oh, I didn't want to do that. Sorry. I have to run all that again. Okay, we're already there. Wait, I'm in the wrong direction. Sorry, wrong file. Okay, so hopefully I'm already, okay. All right, so this says, so the env command launches another command. So it launches the bash command inside what's called a special environment. In this case, there's no arguments passed to env, so there's no special environment created. This just runs bash. Right? You have to do this on a Mac because on a Mac there is no that version of there is no root bin on a Mac, right? Well, there's no root bin bash. There's no root bin on a Mac, right? There is this on a standard Mac, so you can always start up bash this way instead. Right? So if you're on a Mac, use that. If you're in Linux, just write that. If you're on a test, it doesn't matter. Write either one. Right? So again, that line tells the operating system what program should interpret the rest of the file. Right? And this line could be anything. So you can write a Python script and the exact same way. Oops, wrong. That's Jupyter. Here we go. So I have a hello.py. Right? So on the first line, I use a hashbang, and then I tell it where is the Python interpreter on my computer. Right? So on my computer, the Python interpreter is in root user bin Python 3. If you're on a Linux machine, it's almost certainly Python 3 instead of Python. Right? Inside the rest of the script is just a Python script. Right? So there's my Python print command. Right? And I can run this now like that. Right? And you get hello world again, this time using Python. Right? So any interpreter that you want can be used here. Right? So we're using bash, so of course it's the bash interpreter. So it's root bin bash for us. Okay, so the rest of this just tells you how do you actually make a file. Right? So you fire up your text editor, you type in the contents, you put in the first line of the file, right? So make sure you say hashbang something to tell it's bash, right? Save the file, change the permissions on the file so that you have execute permission, and then run the file. Right? And so if you need a reminder, steps 1 through 6 are right here in the notebook. Right? Okay, that's fine. So there's a hashbang explanation right there. It's also possible to run a script directly using bash. So you can invoke a command like that, right? So bash space and then the name of a script will run the script using the bash interpreter, right? If you do it this way, you don't need the hashbang on the first line. All of our assignments, though, assume that you've written the hashbang on the first line so that the TAs don't have to write bash blah in front of it, right? Also, so that my marking scripts don't have to write bash space in front of it. Right, so all of our, so the TAs in my marking scripts assume that you've written your shell script with a hashbang on the first line. Right. You can put whatever you want inside a script, right? Any bash command that runs from the terminal, that runs in your, when you type it into the terminal, will run from a script, more or less, right? So here, I've got a little bash script, right? It runs the fortune command, pipes the output of fortune to calce, prints the fortune using a moose in this case. Right? If you want to run this, so I can't run this directly from the notebook, unfortunately. So I'm going to run it from here. What was that? Oh, fortune cow. That, there you go. Right? And so if you look if you just look inside the script, right, it's just the one command. Well, sorry, it's the one pipeline. All right, so we've seen hello world, we've seen calce in a script, right? Can you do something useful with a script? Sure, you can do lots of useful stuff with a script, right? Here's an example of a useful script, well, semi-useful script, right? So this script here, let's see what it does. So echo, so that's going to print something to standard output. So it looks like it prints out the first line of a bash script to standard output, right? And then there's a redirection. So it redirects the output to the file temp.sh, right? And then it makes sure you have execute permission on temp.sh. So this little script will create the skeleton of a bash script for you, right? I forgot what I called this. I think it's make sh. Yes, it's make sh. Right? So if you run dot make sh, it does nothing, but if you look inside the directory, there's now there's now a shell script called temp.sh that has execute permission set for the user. Right? And so now you can just edit temp.sh, and it even has the first line of a standard bash script on the first line for you. So now you just edit temp.sh, adding the contents of your script, and then save it as a new, save it with a new name, right? And that'll produce a new shell script for you. So semi-useful, right? All right. If you want to comment if you want to write a comment, Bash uses the same comment as Python, right? So the hashtag is the line ending comment. Right. So here's there's the shell script comment.sh. Right. We've got our hashbang on the first line, right? And there's just some comments in this script, right? And it says this program does nothing, and then in brackets almost, right? So every command does something, even this one. Is it here? Yeah, so cat. Right, so there it is, nothing but comments inside the script. Right, you can run it. Right, so what happens when you run it? Well, Bash just ignores all these comments. Right, so if you run it, nothing happens. Right, but every time you run a command in Bash, something happens. So the something that happens is the command sets what's called the exit status for the command. Right? So the exit status is just a non-negative integer number that corresponds, that tells you something about the result of running the command. Right? If the command runs with no errors, the exit status should be 0. How do you look at the exit status? So it's stored in a variable, so I need to use the $sign to get the value of the variable. The variable that it's stored in, oddly enough, is the question mark, and so that's 0. Right? So in Bash, variables are allowed to have funny names. As a user, a user can't create variables with funny names, right? So you're always creating variables that start with a letter. But the shell has a bunch of special variables that are symbolic. The question mark is one of them, which is annoying because the question mark is also used as part of a file name expansion. Right? So Bash, like every other programming language, recycles its symbols or names for other purposes. Here's an example of recycling. Right? The variable, or more precisely, the parameter question mark, corresponds to the variable that stores the exit status of the most recently executed command. Right? So notice that sets it to 0. So the empty program comment.sh does in fact do something, right? It results in the exit status being set. The blue box gives you a little bit more information about these special parameters. Oh, and that shows you how to get the value of the exit status. Okay, so we'll just finish off the commenting part, and then we'll call it quits for today. So comments, it's the line ending comment, right? So it behaves exactly the same as the Python comment. So this is all on one line, right? So there's a comment that says, hey, this might be useful if the user could actually change the name of the script, right? So instead of making temp.sh, it might be nice if the user could say, what is the name of the script? Right? That is not a comment, right? It's inside of single quotes, right? Remember, the single quotes takes away the special meaning of all the characters inside, right? So that's actually an echo statement, right? If you run this, it'll print out hashtag, this is not a comment, right? And comments always terminate a line, so it's not possible to insert a comment in the middle of a line, right? So for example, if you wanted to write ls, that probably should be star.txt, right? You can't stick a comment in the middle of that command, right? The comment ends the line. So this just runs ls. Right? And away you go. All right, so that's it for comments. We'll finish off this notebook in the next, tomorrow, I guess.